Lessons 51 to 53, Algebra 1, Saxon. All right, lesson 51 is talking about linear equations. These are equations that have x's and y's in them, and they create a lines. Things like y equals negative x plus 1. What you're being asked to do in this particular lesson is simply make what I will call an xy chart. In other words, if x is something, what's y? So let's say, for example, x is 0. In this equation, then y equals negative 0 plus 1, or y equals 1. And so that's how we fill out a chart. We say, okay, what about if x is 1? And we say, well, y equals negative 1 plus 1, which is 0. So y is 0. So this is an xy chart. And all you do is you pick x's and y's that make sense, and you can work them out. So in this case, I pick 0 and 1. Pretty much those are my go-tos. I pick 0 and 1 because they're very easy numbers to work with. So then when I draw the graph, I have a 1, 2, 3, 4, 1, 2, 3, 4. There's my y and there's my x. And I just plot these 2 points. So 0 over 1 up, and I put a dot. 1 over 0 up, I put a dot. That is, connect the dots, that's my line. So that's really what you're looking for, is you're graphing these equations. You only need 2 dots to make this work. I could pick 3 or 4, and they would also be on that line. And that's pretty much it. Now, if the equation looks like it's more complicated, there are some tricks to it. So for example, y equals negative 1/3 x plus 2. If you're going to graph this or try and fill out an xy chart, chances are pretty high if you just pick a number, it's going to be a fraction. But let's do that. Let's go xy, and again, I'm going to go to my what if x is 0. Well, that's y equals negative 1/3 times 0 plus 2, which is just equal to 2. So the first dot is kind of easy. The second dot, if I have a fraction here, what I always do is I just use the number in the denominator. So for example, x is 3. Then this becomes y equals negative 1/3 times 3 plus 2. Notice I picked that because the 3's will then cancel, and I end up with negative 1 plus 2, or 1. So now I have 2 clean dots that I can use on my graph, and I don't have to worry about having fractions that I'm trying to locate on this graph. So 0 over 2 up, make a point, 1 over, or 3 over 1 up, make a second point, and again, there's my line. So again, a little trick, if you have a fraction and you're trying to fill out an xy chart, use the denominator for your x, and that will generally cancel out. Makes it kind of handy. That's lesson 51. And let's move on to lesson 52. Lesson 52 is about adding fractions with unlike denominators. Okay, so let's start with reminding you what that means. So let's say I have 1/5 plus, let's say, 3/10. Okay, you cannot add fractions if the denominators are different. However, I can think of this as 1/5 plus 3 times 2 times 5. In other words, if I factor the denominator, I can look and I can see, well, they almost look the same. This has got a 2 times 5. This one only has a 5. So if I multiply top and bottom times 2, now the denominators are the same, and I end up with 2 plus 3 over 2 times 5, which is 10, or 5/10, or 1/2. So that's easy enough to do. You just get the denominators to, and I'm going to use the term, look the same. So let's look at it a little bit more complicated. Let's say I have a over x squared plus b over y. Well, here I have denominators do not look the same. So if I want to make them look the same, how about I multiply top and bottom times y, multiply top and bottom, in other words, numerator and denominator times x squared. Now this has got a yx squared on the bottom, this has a yx squared on the bottom. So whatever it is, it's going to be a yx squared. And I always put an alphabetical in the final answer, so x before y. So I end up with ay plus bx squared. And that's the answer. So it is getting the denominators to look the same is my goal. So what is lesson 52? So that's a review. Lesson 52 is, well, what if they look even uglier? That's really all it is. So let's say I have a over x plus b over x plus y. Do not get this stuck in your head that something is different. It's not. Do these look the same? Does x look the same as x plus y? The fact that it has an x in it doesn't change what it is. Think of this as an x plus y thingy and an x thingy. They're different thingies. So if I want them to look the same, what if I multiply top and bottom times x? Now there's an x times x plus y, and top and bottom times x plus y. Now they look the same. So my answer is going to be x times x plus y on the bottom, and I'm going to have a times x plus y plus b times x. And that's pretty much it. I can multiply it out by using the distributive property here, and this becomes ax plus ay plus bx over x times x plus y. There's no reason to do that. If I could multiply it out and then cancel stuff, that's fine, but in this case, these are all different. You can't cancel them. This is the fine answer. So that's what you're looking at here in this lesson. Let me give you a couple more examples, and lesson 52 will become mostly clear to you. So let's say, for example, I have a more complicated one, x over y minus b plus c plus d over m. Now, first thing your brain is thinking is, how come these things are so ugly? The answer is they represent things that you might see, primarily in a science problem. They are what we call variables. X doesn't mean anything, y doesn't mean anything, but in a particular problem, x might mean the velocity, or y might mean acceleration, or b might mean magnetic field. These are all different things. So the question is, how do you put those all together mathematically? So here's the deal. Do the denominators look the same? No. This has got, think of this as a 1. This has got a y, a 1, and an m. They don't look the same. So let's give everything a y. But if I do on the bottom, I got to do that on the top. And so let's put a y here, and that one's got a y. Now they all have a y. This one doesn't have an m. Let's put an m there. This one doesn't have an m. Now they have an my, and my, and my. So the answer is going to be my on the bottom. I have mx, that's the first one, minus bmy, that's the second one, plus y times c plus d. I could write c plus d times y, but generally when you have a single thing times a double, you put the single thing there. And so that's how you do it, is you get the common denominators to look the same. That's all there is. So it's not any more complicated than what you've been doing. It's just these problems look more complicated. All right, last lesson. Lesson number 53. Number 53 is a reminder about exponents. So 3 to the 4th times to the 5th power. Okay, what does that mean? That means it's 3 times 3 times 3 times 3 5 times. Times 3 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 3 times 3 times 3 times 3 times 3 times 3 times 3. Okay, that's what it means. It's 3 to the 4th 5 times. So, well, how many 3's is that? That's 3 to the 20th. If you think about that, is there a rule that we can come up with? Yes. What's 4 times 5? 20. So whenever you have something to a power, let's call it n, and that whole thing is to another power, it's just a to the n times m. So anything to a power, when you put that in parentheses times that, that means you're just doing it that many times. So that's the rule. Okay. In the same way, it can use negative numbers. Let's say you have something like x to the minus 4 to the minus 2. Well, what's negative 4 times negative 2? That's x to the 8th. it's pretty simple. You don't have to write out a bunch of x's. Doesn't matter whether they're positive or negative. You don't have to get rid of the denominator or put them on the bottom or put them on the top. That's what the rule is, and that helps. Okay, so another variation of that is, what if you have something like x to the fifth over x to the third? Well, again, understanding what that is, that's 5 x's on the top and 3 x's on the bottom. Well, those cancel and I end up with x squared. Again, looking at the rule, if you have what's 5 minus 3? 2. So if you have x to some power over x to some other power, it's going to be just x to the top minus the bottom, n minus m. And that's the answer. You just take the top exponent minus the bottom exponent. And so that's kind of the two rules. X to the n to the mth is equal to x to the m times n. And the other one is you take the top minus the bottom. And those are the two rules that are used for this. And it'll help you in some more complicated problems. Let me give you an example how you would use this on a practice problem for your homework. Practice problem might be something like 3 to the 0th, y to the negative 2, z to the 5th over x to the 3rd, and all of that to the negative 3. So how would you do that? Well, first of all, you think of it this way: 3 to the 0th, y to the negative 2, z to the 5th, to the negative 3rd, over x to the 3 to the negative 3rd. So the first thing is, when you have a fraction and the whole thing is to some exponent, it's just the top to that exponent and the bottom of that exponent. So you can kind of separate it. It makes it a little bit easier. Now, using my rules, where I have something to a power to something else, well, what's 0 times negative 3? 0. So what's 3? So this becomes 3 to the 0. And then this times this is negative 2 times negative 3 is 6. This times this is negative 3 times 5 is negative 15. And here, negative 3 times negative 3 is, or times positive 3 is 9. So 3 to the 0s is 1. So y to the 6th, z to the negative 15, x to the negative 9. And if I want to make this to where it's only has positive exponents, that's x to the 6th, or y to the 6th, x to the 9th, over z to the 15th. Remember, negative exponent makes positive by going up. That one goes on the bottom and turns it positive. So this complicated guy turns into this simpler guy using these rules. But again, reminder, just take the top piece, do that, and then take the bottom piece and do that with the same exponent. And then just deal with it. Shrink it down until you're done. And then if the question asks you to have all the answers positive, that's how you would do it. If they were to say all the answers are in the numerator, you would say, okay, that's y to the 6th, x to the 9th, z to the negative 15th. So you're going to be asked to do one or the other of these. And that's the end of lesson 15. Or not, that's 53.